how ocean life and fisheries management impact the ocean's capacity to mitigate climate change. We'll hear from 5 experts on the science behind the ocean's role in climate mitigation and fisheries management opportunities to help drive significant climate action, and then we'll open up to a panel discussion and a Q&A. We have a Mentimeter online if you would like to submit questions. If you just go to menti.com and enter the code 26874236. So the ocean is the greatest unsung climate hero. It's the largest ecosystem on the planet and the most important carbon sink. But ocean health is in jeopardy from incredible overuse, overexploitation, and it's really impacting on the ocean's capacity to continue to perform its important role in terms of absorbing and sequestering and storing carbon and buffering the atmospheric changes. Since industrialisation, or in the last 50 years actually, the ocean has absorbed over 90% of the excess heat that humans have generated. And if it were not without that absorption, our atmospheric temperature rise would not be just 1.1 degrees, but actually over 35 degrees hotter. So the ocean is really performing an absolutely critical role, and yet I guess it's still a little bit on the periphery of the climate agenda, so that's why we're here today. So these climate services, in terms of that heat absorption and the carbon storage, are not merely chemical and physical processes. They rely on a functioning ocean carbon pump, and that relies on an ocean full of marine life, fish, and healthy habitats. So our speakers will give an overview of some of the science about how this works and then how we can improve the mitigation capacity and adaptation capacity of the ocean through management options, but also through the UNFCCC. So to start us off, we're going to show a video from Professor Alex Rogers from the Oxford University, who's also the Science Director of Rev Ocean. And apologies, he couldn't be here with us because we only had one delegate. So we have a video presentation from him. I'll just find it.
Distinguished ladies and gentlemen, many thanks for listening to us today. I'm Professor Alex Rogers, and I'm going
Apologies, everybody, that's my fault. Presentation mode is not the same as the computer mode.
to talk to you about the carbon cycle, life in the ocean, and climate mitigation. So I thought I'd start off by defining what blue carbon actually is. Blue carbon refers to marine ecosystems that sequester and store carbon with a significant impact on atmospheric CO2 levels. Storage of carbon through these systems must be over a long term, preferably centuries and millennia. It must be influenced by human intervention. So, for example, through managing fisheries, we must be able to improve it, or restoring ecosystems. And it's important to consider the implications of ecosystem and biodiversity loss that actually also release carbon dioxide into the atmosphere as a result. So up to recently, the emphasis has really been on coastal blue carbon. And these are ecosystems like mangrove forests, salt marshes, and seagrass beds, where there is living biomass above the ground and living biomass below the ground. Also, these ecosystems trap organic carbon as sediment, immobilizing it underground within these systems. There has been some controversy over macroalgae or seaweed or kelp as a blue carbon ecosystem. And this is because this has little of this in situ trapping of organic material. And instead, organic material is actually exported from kelp beds or kelp forests and trapped in other ecosystems. And if we look at the amount of carbon sequestered and stored by these ecosystems, it is quite substantial. On a per area basis, mangrove forests are more efficient at soaking up and storing carbon dioxide than an equivalent area of tropical rainforest. So you can see here carbon sequestration in teragrams of organic carbon per year, and carbon stocks in billions of tons of carbon per year, petagrams of carbon per, in those stores. Unfortunately, these ecosystems are still being lost, and you can see here estimates of the annual losses of these ecosystems and the equivalent loss of CO2 to the atmosphere as a result on a per annum basis. More recently, we've realized that other marine ecosystems and other elements of marine ecosystems also are involved in the carbon cycle. And the first of these was whales. So it was realized that through the death of whales and the sinking of their bodies into the deep ocean, that contributed to the deep ocean carbon sequestration. However, it's more recently been realized that living whales actually also add to carbon sequestration in the ocean through the release of iron through defecation, which acts as a fertilizer, stimulating primary production. And in this case, for sperm whales, increasing the carbon sink by 200,000 tons per annum. And I think this is in the southern ocean. This, of course, is a small number compared to the overall amount of carbon absorbed by the ocean every year. But it just goes to show how these processes contribute to carbon cycling in the ocean in general terms. So whale carbon and oxygen flux essentially, as I said, happens through a process of fertilization. Essentially, the sperm whales feed in deep water on squid and other organisms, and then they come up to the surface to breathe, where they defecate, releasing iron, which is a micronutrient in the ocean, certainly in places like the Southern Ocean, which are iron deficient, and that stimulates phytoplankton primary production, and a portion of that production sinks into the deep sea. Well, we've realized that many other aspects of ocean ecosystems contribute actively to carbon sequestration in the ocean. So I've just described the whale pump, but one other example that I will refer to in a bit more detail is twilight zone carbon. And here, the world's biggest migration, which occurs every day when marine animals move up to the surface from deep water at night time. They feed at the surface overnight, and then as the sun comes up, those animals dive back into the deep sea, where they digest their food, but also release some of that carbon which they fed upon. And this active transport of carbon really does move quite large quantities of carbon into the deep ocean, where it's stored for hundreds, if not thousands of years. And there are many other examples of these types of processes in the ocean. One question that I think we have to ask with these types of processes is whether humans can actually influence these carbon sinks. And I think the simple answer to that is yes, they can. So climate change in itself, for example, is predicted to reduce ocean primary production. So through this human-induced process, we're actually going to see potentially a weakening of carbon sink as a result of sinking of primary production into the deep ocean. It also reduces the size and productivity of fish populations, and of course warming of the ocean is causing substantial loss of habitat through the effects of temperature-induced mortality or sea level rise. Fishing, we know, reduces the biomass of fish and other organisms in the ocean, which of course reduces these active transport pathways of carbon, but also fishing methods like trawling actually release carbon from the sediment as they disturb the sea floor. And this, of course, is a means by which humans are actually reducing the effectiveness of ocean ecosystems as a carbon sink. And of course, there are other activities which potentially impact on marine ecosystems, such as dredging the seafloor, pollution, and so on. And just to home in on one of these examples, there was a recent paper published which suggests that up to 4.9 million square kilometres of the seafloor are actually trawled per annum. This is about 1.3% of the overall area of the seafloor. And it's been estimated that in the first year of trawling of a fresh area of seabed, around 1.5 billion tonnes of carbon is released as a result of this activity. These carbon emissions actually reduce in subsequent years as those carbon stores are gradually depleted by the activity of trawling. So this reduces to about 500 million tonnes of carbon per year. And homing in on another example I mentioned, that of this active transport of carbon through migration of marine life from the surface to the deep sea. It's now been estimated that this involves, just in the fish alone, about 10 to 15 billion tonnes of biomass of these organisms moving from shallow to deep water. And this has been estimated to be responsible for the active transport of about 900 to 3,600 teragrams of carbon per year from the surface into the deep sea, where it's stored, as I said, for the long term. And of course, now we're planning to actually fish these stocks of fish, which up to now have not been exploited, or at least not been commercially exploited recently. So we really have to think about the implications in terms of the carbon cycle of opening up a new fishery on these twilight zone fish species. As I said earlier on in the talk, kelp forests have been looked at with some controversy over whether or not they contribute to carbon sequestration. Scientific evidence is now accumulating that they, although they do not sequester carbon in situ, they do produce particulate and dissolved organic material, which is exported to other ecosystems, potentially sequestering up to on average around 173 teragrams of carbon per annum. And that's in sediments of continental shelves, of the deep sea, and also in places like mangrove forests. So there is no doubt that kelp forests do contribute to carbon sequestration, but I think the problem here is whether or not we end up double counting that carbon in terms of ecosystems like mangrove forests. Of course, this does open up the opportunity, if you like, of actually culturing seaweed, which not only produces food and other useful byproducts, potentially such as biofuels, which of course mitigate our use of hydrocarbons, but also contributes to carbon sequestration in the ocean. At the moment, the annual production of seaweed culture in the oceans is about 27 million tons. This is growing at about 8% per year, but it's been estimated that potentially we could be cultivating seaweeds over 48 million square kilometres. And at the moment, only a tiny fraction of this is used. So this really does have a strong potential to contribute to carbon sequestration in the ocean, and is something which we could be doing. But also we've got to bear in mind that seaweeds, through their products, could also allow us to avoid using other materials such as hydrocarbons or plastics, which contribute to CO2 emissions. So just to summarize that, coastal blue carbon is now recognized as a certifiable mechanism of carbon sequestration through ecosystems such as mangrove forests, salt marshes, and seagrass beds. Oceanic blue carbon has enormous potential and is clearly affected by human activities. We need to really undertake more research to understand the mechanisms and the quantities of carbon that can be sequestered through these pathways, but also how our management decisions in the ocean, or lack of management, can lead to carbon emissions. And ocean management, including of fisheries, can really reduce direct CO2 emissions, but also the indirect emissions coming from things like disturbance of the seafloor, habitat destruction, and really fishing down the food web and altering the structure of marine food webs. And finally, as I said, our understanding of sequestration of carbon by macroalgal forests or kelp forests is increasing, and it may be the case that seaweed farming may become certifiable for carbon sequestration in the future. And with that, I would like to thank you all for listening. Thank you.
Excellent. And that message was from Professor Alex Rogers. Up next, if I have it on the right screen, we have a presentation from a joint presentation, actually, from Astrid Fuchs, who is the policy lead at Whale and Dolphin Conservation in Germany, and Melanie Virtue, who is the head of the aquatic species team at the Convention for Migratory Species. And these two will speak specifically to the contribution of whales and marine megafauna. Over to you.
Thank you. And thank you all for coming today. So as Rebecca said, my name is Astrid from WDC, and I'm going to talk about my favorite subject, which is not only whales, but actually whales and their poop. As you just heard, this is quite important for the ocean, so it is a bold statement, but emerging science is demonstrating that there might be a lot of truth in it, that save the whales, save the world might actually have some truth. WDC is working to make sure this science and the results of ongoing studies are ultimately integrated into climate and biodiversity policy at a regional and global level. And one of our main goals is actually to create a safe and healthy ocean for all cetaceans to thrive in, and to achieve this, we need to protect whales so they can help protect us from the devastating impact of climate change. And according to Dr. Heidi Pearson and colleagues, Dr. Pearson is one of the leading scientists in this field. There's been more than an 80% reduction in the amount of carbon captured, stored, or sequestered due to industrial whaling and bycatch of cetaceans. And considering just the carbon that is sequestered or removed from the atmosphere for more than 100 years, the removal of whales from the ecosystem due to industrial whaling has caused the loss of an estimated 300,000 metric tons of carbon sequestration per year. And using carbon equivalencies from the US EPA, to put this in perspective, this is analogous to losing the carbon sequestration ability of more than 500,000, so over 500,000 hectares of forest in 1 year. And this is still a very broad and preliminary estimate and is likely on the lower end of the carbon sequestration abilities of cetaceans, and we still have lots of things to learn in terms of the roles of whales and dolphins in nutrient and carbon cycling, but a handful of studies on a handful of species have provided quantitative estimates. So we still have a way to go to further support and refine these numbers. You just heard about the whale pump from Professor Rogers, I will just leave you with this beautiful picture for a second here, because you just learned how whales are actually contributing through the whale pump. But a very exciting thing we are supporting is emerging science on this subject. So we are actually scaling up and facilitating the filling of knowledge gaps in this area. And the Alaska Whale Pump Project, which is led by Dr. Pearson, seeks to determine the extent to which migratory humpback whales circulate nutrients and carbon in Southeast Alaska and their impact on marine productivity and carbon sequestration. And this picture actually is a beautiful fecal plume, as we call it, left behind by a humpback whale. And Dr. Pearson, the leader of the study, states quantifiable data on the whale pump hypothesis is limited, as I just said, and so this project will empirically test the theory by determining if and how humpback whales facilitate nutrient and carbon cycling, and ultimately the impacts on marine productivity and carbon sequestration. And also, whales fulfill another important ecological function due to being migratory species. They generally feed during the summer in polar regions in high latitudes when ice has receded and there's a burst of life to feast upon. And this is indicated here by the yellow arrows. And they build up their layers of blubber and fat and get ready for return to lower latitudes towards the tropics, where they actually give birth and nurse their young and breed. And recent science shows that on this epic migration, whales bring in nutrients via their urine, placentas, carcasses, and slough skin from highly productive feeding grounds to these tropical regions, which have reduced nutrient availability. And the green arrows here indicate that this much higher and direct deposit of nutrients to tropical waters than they transport to polar regions. And this we call the great whale conveyor belt. And all of these nutrients actually work in similar ways to their fecal plumes by helping phytoplankton to grow and providing food for other ocean life. And this is another area of research that we are proud to provide funding for. What is less well understood than the whale pump actually is the impact that whales make as they undertake some of the longest migrations of any species. And the idea that whales might be responsible for a vast oceanic conveyor belt of nutrients has enormous implications for our understanding of marine ecosystems and nature-based solutions to climate breakdown. And this image here shows actually, it's not very tasty, I would say, but it's very important. It's a whale placenta left behind after giving birth, and it's very, very rich in nutrients. So actually also helps whales fulfill their ecological function in the ocean. And then finally, and also something that Dr. Rogers already touched upon, are whale falls. Because even after death, whales are important to keep the ocean and our climate in balance. Like all life on Earth, their bodies are carbon-based. So essentially, big animals like whales are important for keeping carbon out of the atmosphere. And when a whale dies, its carcass most often sinks to the ocean floor, and it's taking all that carbon with it, actually. So the carbon in its body can then be considered to be locked away into the sediment and other sea creatures, and is unable to return to the atmosphere for thousands or maybe even millions of years. And at the current hugely reduced reduced population size of whales across species, they are still taking about 145,000 tons of carbon to the seafloor every year. These whale falls are also very important to the ocean ecosystem in other ways. So there's extreme food limitation down there, and there are specialized creatures who have adapted to feed on them, and more than 200 species can actually be sustained by a single whale fall. So yeah, what does more whales mean? So it means more carbon dioxide absorbed from the atmosphere via the whale pump. It means more carbon sequestered via whale falls, more nutrition for the marine ecosystem via the whale pump, conveyor belt, and whale fall mechanisms. And all of this leads to more fish and more biodiversity. And another added bonus is actually that more whales means more opportunities for us to see them responsibly, which can have tremendous impacts on our well-being and also boost ecotourism opportunities. So ultimately, we get a healthier ocean and a more resilient ocean as well, and a healthier and more resilient planet. So every natural process that we can actually help restore is another step in the right direction to try and save our planet from climate breakdown. And for that, the huge portion of the planet that precious few of all of us ever see, the high seas, must be conserved and restored. And whales and the conservation measures needed to protect them as umbrella species can actually help us do that. So thank you very much for listening.
Shall I? Yes, hi. So I'm Melanie Virtue, and so I'm going to continue on this theme. So we need more migratory whales in the ocean, and so I work for the Convention on Migratory Species, running the marine team, and that's exactly what we're trying to do. Next slide. And so I work for the Convention on Migratory Species. We're based here in Bonn. And so we're a global convention specialized in the conservation of migratory species and their habitats and their migration routes. So we deal with marine species, we deal with terrestrial species, we deal with avian species, and in a way, the marine species which I work on, have the most fascinating migrations. Astrid's slide of the great whales and their, migrations from the poles to the tropics every year are tremendous. We also have sharks that wander across the oceans in a slightly more erratic manner. Turtles, who also wander widely across the oceans, and so. I'd like to just talk a little bit more about that. On to the next slide. So, but just widening out from whales then to other marine species, they face these tremendous threats that we all know about: the unsustainable fishing, loss of habitat, ghost nets, bycatch, plastic pollution. And of course, then on top of all this, now there's climate change. So these species can be, in a way, like a victim of climate change, which comes on top of all the other threats that we've already, put in their way. But as we've said, they can also be a natural solution to mitigate climate change. So it's in our interests to try and work on solving some of these more proximal threats as well, so that they can help us mitigate carbon, climate. And here we have the slide again. It's the best slide. Everyone likes it. It was actually created by our parent organisation, the United Nations Environment Programme. So I won't spend any more time on that. We know why the cetaceans are so important for the oceans. But then slightly lesser known, and though Professor Rogers did touch on it, seagrass beds are also tremendously important as a key habitat for climate change mitigation. Seagrass beds, which are found in shallow coastal areas, cover only 0.1% of the ocean floor, but sequester up to 18% of ocean carbon. So they're really punching above their weight. And these seagrass beds are the sort of natural food for dugongs and manatees, and that's a dugong here, and marine turtles, of which there are 7 species around the globe. And by grazing the seagrass beds, these animals then keep them healthy and keep them functioning as a carbon sink. Not only does, like grazing makes grass grow, but then they also spread the seeds around and create sort of greater diversity. And so, as we said, oceans are huge carbon sinks. Phytoplankton and seagrass absorb large amounts of CO2. Whales are helping in this process, fertilising phytoplankton, dugongs and sea turtles, keeping habitats healthy. And so basically, these species are helping to sequester carbon. So then for CMS, we again are dealing with this dual thing where on the one hand, our species are being threatened by climate change. It's changing their migration patterns. A lot of habitats are changing. Food availability is getting messed up. Sometimes, the herring run has happened earlier before the whales get there or later. And so there's a lot of stress on our migratory species. And so all the parties to CMS, the countries, have taken steps to really look at climate change from both of these sides. So we have a big sort of policy area on climate change. We have a program of work, a sort of expert groups looking at the different ways that we can both help our species mitigate the effects of climate change and help so that our species can help humans mitigate climate change. And then we have also another resolution on the management of whales and their habitats, which again stresses the importance. Our countries are recognising the importance of whales in the ecosystems, and within that, asking us then to work very closely with the IWC, the International Whaling Commission, go on, which is an interesting collaboration because the International Whaling Commission was set up originally to regulate industrial whaling, which again we've heard how many whales have been taken in that process and the effect it's had on the ocean. But more and more now the IWC is looking also at the other threats facing the great whales and the ecosystem role that they are occupying, and how we can best protect them. So we are working together. CMS and IWC are working together. We last year had our first joint workshop on the ecosystem functioning of whales, or the function that whales play in the ecosystems. It's a long process. There's a lot that's still unknown. There will still be much further work to do on this. And then we're also working with the UN Oceans Initiative, again on addressing some of these the threats to our species, ship strikes, underwater noise, other forms of pollution, bycatch and entanglement, and then of course on the flip side, marine wildlife watching can often be a positive thing, but it also has some negative impacts to the animals when not done properly. And finally, we're also implementing an ICI climate project. This is funded by the government of Germany, really on seagrass ecosystems and the biodiversity, such as the wonderful dugongs that are helping to protect the seagrass beds. And this is to safeguard food security and resilience in coastal communities as the climate is changing. And so I'll leave it there. Thank you.
Excellent. Thanks, Melanie. So Melanie just started the transition for our event from informative science to policy and management. And our next recording, again, apologies that Clara couldn't be here, but we have Clara Johnson from the Marine Conservation Society in the UK, and Clara will talk about climate-wise fisheries and how we can use fisheries management to make a difference for climate. mitigation and adaptation.
Thank you for inviting me to speak today. My name is Clara Johnston. I'm the Fisheries Policy Manager at the Marine Conservation Society. I'm going to talk to you about climate smart fisheries, what this means, and how this could be achieved in the UK and elsewhere. So firstly, a quick introduction to the Marine Conservation Society. We are a UK-based charity fighting for cleaner, better protected and healthier oceans. For over 30 years, we've been working with communities, businesses and governments to improve the health of our oceans and minimise the impacts human activities are having on them. So I work within our fisheries and aquaculture team, where we focus on advocating for sustainable and responsible fishing and aquaculture, and we also run the Good Fish Guide, which supports businesses and consumers to make ocean-friendly decisions when choosing seafood. So many recent publications, including the latest report by the Intergovernmental Panel on Climate Change, or the IPCC, have highlighted the severity of the issue we are currently facing in relation to climate change and its future implications. However, despite being in this situation, the IPCC has advised that strong and sustained reductions in emissions of carbon dioxide and other greenhouse gases could quickly improve air quality and help to stabilise global temperatures in as little as 20 to 30 years. However, to achieve this, we need to take action now. In 2019, UK MPs approved a motion to declare both the environmental and climate emergency. Since then, we have seen the implementation of legally binding targets in the UK to reaching net zero by 2050. This goal can be achieved in two ways which work in tandem. So the first is to reduce existing CO2 emissions by reducing sources of greenhouse gas emissions as much as possible. And the second is to actively remove greenhouse gases from the atmosphere. And it's vital that all sectors play their part in contributing to this. And the fisheries sector is no exception. A healthy planet needs a healthy ocean. The oceans cover over 70% of our planet. They provide more than half of the oxygen we breathe and also absorb nearly a third of our carbon emissions. However, fisheries present a complex problem. They are both vulnerable to the impacts of climate change, whilst also contribute to anthropogenically driven climate change. Fisheries contribute in a number of different ways, including the disturbance of blue carbon habitats and marine ecosystems, the extraction of fish, disruptions to ecosystem function, and industry-wide fossil fuel use. So hopefully most will be familiar with the term blue carbon, but for those who aren't, blue carbon refers to carbon captured and stored in coastal and marine ecosystems, particularly seagrass meadows, salt marshes, wetlands, mangroves and seaweed. Carbon is also stored in seabed sediment and is sequestered by living organisms including fish and calcifying organisms such as corals and mollusks. So thankfully, the role that the fisheries sector has to play in achieving net zero is being recognised in new UK legislation. In particular, the UK Fisheries Act, published in 2020, contains a climate objective which states that adverse effects of fish and aquaculture activities on climate must be minimised. This is an important recognition, as the fishing industry's carbon footprint, combined with its significant impacts on long-term carbon capture and storage in blue carbon habitats, makes the industry an important one to consider when designating greenhouse gas reduction and climate mitigation strategies. So what can the fisheries sector and governments do to achieve these targets? So we advise that strategies should focus on the reduction of blue carbon habitat disturbance and unsustainable extraction, whilst also taking steps to move the industry towards net zero emissions. So firstly, we need to build a clearer picture of blue carbon habitats and the impact different fleet segments are having on habitat disturbance. Some of these areas will be within existing marine protected areas. However, it's also important to identify blue carbon habitats in the wider marine environment as well. This will help with the implementation of policies which could effectively protect these habitats and reduce pressures from fishing activities such as bottom-towed fishing gear. Governments also need to ensure fishing pressures are at or ideally below scientifically recommended levels. While the impact of fishing extraction is smaller than the impacts caused by habitat disturbance, healthy and abundant fish stocks are a vital part of securing and improving the health of our oceans and must therefore play an important role in achieving climate targets. Finally, steps need to be taken to reduce greenhouse gas emissions from the fishing vessels themselves. This is going to require a lot of political and financial assistance, which will be needed to support the infrastructure changes and ensure a just transition to new energy efficient sources such as hydrogen or electric powered vessels where possible. If such strategies are adopted, it should help to future-proof UK fisheries and bring about the recovery of ocean health, whilst also helping to meet the triple challenge of sustainably feeding a growing population and staying on track to meet UK 2050 climate targets. Thank you very much for listening.
Okay, and our final speaker is Julika Tribukait, Policy Advisor on Coastal Ecosystems from WWF Germany. And it's going to work perfectly. And Julica is going to tell us about exactly how this is all relevant and can be actionized through the UNFCCC.
Yeah, thanks, Beck. Thanks for the introduction. That's actually, what I'm going to try to do after we've heard about how specific species, how specific activities in the ocean and around the ocean are relevant. I'll try to connect everything back a bit to where we are actually and what's negotiated here, and on how to best strengthen ocean action under the UNFCCC. So let me take you back a bit, a few years back. I think from my view, the first milestone and really turning point obviously was the IPCC SROC report. So the first thematic report focusing really on impact and risks of climate change on the ocean and the cryosphere. So the key findings were made obvious and very public for the very first time together with other thematic reports. This was, as I said, really a milestone and raised awareness about how the ocean is affected. But of course, it talked mainly about impacts and risks. And we also want to acknowledge that the ocean has a lot to contribute. So in terms of mitigation, adaptation, and resilience. So what WWF did at the time was looking at all the thematic reports that came out and also the IPBES report that was released around the same time, and looking how they all fit together and what's needed with regard to specific biomes. So with regard to the ocean, we came up with 3 major recommendations. First of all, quite obvious, protect and restore blue carbon habitats. We've heard a lot already about which ones account for that already. So far, the focus has been a lot on carbon coastal ecosystems, but we've heard oceanic ecosystem potential is huge as well. Secondly, we also need to think about MPAs in that context. So the goal of 30% protected ocean area by 2030 is really key also with regard to tackling climate change. And last but not least, and the last speaker talked to that, managing all fisheries sustainably and equitably is also climate action. But now, how to actually integrate all that into the UNFCCC and relevant processes, and how to make policymakers aware of the role of the ocean. So we focused a lot on case studies first, so showing how specific ecosystems contribute. And that, of course, needs to be accompanied by data. So we've heard a lot about that today. Blue carbon stock assessments have been really at the core of our activities over the past years. One example is shown here, Kenya's mangrove forest. But of course, at the same time, accounting for the adaptation capacity these ecosystems bring along is extremely important. What did we intend with, for example, the blue carbon stock assessment in Kenya? Actually, that the government would include mangroves in their NDC, in their updated NDC. So that's basically one of the key actions to take, and the key message to governments: include marine and coastal blue carbon ecosystems in your NDCs. There was an analysis conducted actually in 2021. There is an updated version available now after the Glasgow COP, which looked at the existing NDCs and which one includes ocean action, basically. So in total, by June 2021, 33 countries had included coastal and marine nature-based solutions in their updated NDCs. 3 on mitigation, 6 on adaptation, but impressively, or I at least found it was impressive, 24 included both, which I think is really also the beauty about ecosystems or nature-based solutions in NDCs, that most of the time they really contribute to both, and it's good to see that many countries acknowledge that. The number has been increasing, but of course there is still potential, and I think that's a key point for all of us to push for. So the US Special Presidential Envoy for Climate, John Kerry, had made a very good statement, actually, and I think that's very true and a good message to carry on. You cannot protect the oceans without solving climate change, and you can't solve climate change without protecting the oceans. So after that, or relating to that, WWF at one point sat back and said, okay, we have oceans included in some NDCs, but in preparation for the COP before Glasgow, so Blue COP in Madrid, we started thinking about, okay, what is really needed to integrate actually ocean and climate action, to bring them together. And we identified 4 main areas. So obviously, first of all, raising ambition and deliver stronger and sustained mitigation and adaptation actions. That refers to the integration of ocean action in NDCs and NAPs as well. But of course, top line, and that needs to be said at one point, is of course emission reduction and fossil fuels as well, because we need to sustain the function of the ocean to do or to deliver on mitigation and adaptation. Secondly, make nature a key part of the solution. It's a principle that refers to really build linkages to other important conventions, like the CBD, for example, the Ramsar Convention, and to ensure that synergies are used and built. Put people at the center clearly refers to the fact that we can never forget about the people that actually are the ones protecting those ecosystems, so mainly coastal communities, and their rights. So that's utterly important to keep in mind and should be pushed forefront. And last but not least, we cannot really advance ocean action if we don't have the funds for it. So joining the climate and ocean finance agenda is key. I just learned yesterday, I think that only about 2% of GCF funding actually goes into ocean action. So that's something that definitely needs to increase when we consider that 70% of the Earth's surface is actually the ocean. So also a very important area to work on. So what we have now is the Ocean and Climate Change Dialogue under the UNFCCC, which is a major achievement. So this year, actually next week, the 15th, the first annual dialogue is going to take place. There was already a dialogue taking place, a virtual one mandated by COP25. But COP26 now gave us the mandate to hold this dialogue annually. So that's really a major achievement, a good forum, and I actually strongly encourage everyone to attend the dialogue. There is also good room for intervention, so that's really something you should consider and spread the word. But what else? There is this dialogue now, and what's the purpose of the dialogue? So we've talked about integration of ocean action into national commitments, but there's other processes under the UNFCCC that we should have a look at, and where actually good guidance exists. So oceans in the global stocktake, that's really key. The information collection phase is taking place, so delivering information on how the ocean contributes, and we've heard quite a lot about that today, needs to be included in the global stocktake. The report I'm referring to here is very specific, focusing again mostly on coastal ecosystems, but gives very, very concrete information on where to integrate and where to find relevant information. So that's really one thing or one work stream to keep an eye on. But we also need to mainstream the ocean further. This options paper, the updated version, was published just a few days ago, gives a brilliant overview on which work streams and processes under the UNFCCC already include ocean aspects or have the potential to. So there is an oceans expert group under the Nairobi Work Programme, for example. There is discussions on oceans and also the Marrakesh Partnership, for example, which is not listed here, as it's a non-state actor process. And there is potential to include more with new and upcoming processes. So I actually joined sessions on Article 6.8, non-market approaches, earlier this week. They are talking about a matchmaking mechanism to enhance action and enhance collaboration. And I think that's a perfect entry point, actually, for ocean action, and also to increase funding and support for ocean action under the UNFCCC. And there was specific reference made also to blue carbon in the Glasgow Climate Pact with regards to Article 6.8. That's just a glimpse. There's millions of opportunities. I just wanted to provide you with a brief overview. And as I said before, join the Ocean and Climate Change Dialogue on June 15th and help spread the word and increase ocean action under the UNFCCC.
Brilliant. Thanks, Julica. So now we're going to open to a panel discussion and Q&A. And it would be really interesting to hear your reflections. I just wanted to first of all start with the panelists, but then I'd really like to hear from you in the audience about this. It's quite interesting working specifically on ocean issues, but then coming into the climate change action space through oceans, whereas we recognise that a lot of people who are looking at oceans and coming from the climate change space, sometimes it's quite difficult to get traction. And certainly I've experienced that, and I'd just be interested to hear from you as the panellists what your experience is, just considering, as we've all said, you know, the ocean is 70% of the planet. It has absorbed all of this heating and all of this carbon, and yet still it still seems a little bit of an add-on. And maybe, you know, why do you think it is that we are struggling, or that it is so much harder to really put oceans into and mainstream it in the climate dialogue? Julika, do you want to start first?
Sure, yeah, I think there's a million reasons. So first of all, as people working in the ocean community, we know that it's always our task to make sure that the ocean is not forgotten. So it's not only within this process, it's also under the CBD, where we keep on repeating, okay, it's not only about land, it's also about the ocean. And people keep forgetting about the ocean, I think mainly because it's not as tangible, actually, as land. So that always causes a problem. But then with regard to international policy processes, we also cannot forget that actually the oceans are areas beyond national jurisdiction. So that always causes a problem. I mean, there is, of course, the opportunity, which has been used already, to include coastal zones accordingly. But when we also want to include ocean carbon potential, as we were talking about today, that's something to think about. Then I also think lack of science is something. So we have the ocean, the Decade on Ocean Science going on right now. They identified gaps, and we know there is some more research needed, definitely. But I think that's not all. I think quite often it's also about the translation of scientific findings to policymakers, which is utterly important, because we might know and think it's extremely important, we have the data, but talking to the people and negotiating here is something very different. So I think we need to find other ways to explain to them how the ocean is important or how coastal and marine ecosystems are important. Just to give a very brief example from a project I'm working on, which is on mangroves. So what we basically try to do when we talk to policymakers is to talk about their socioeconomic value. That's something that is interesting, obviously, to policymakers, and also to highlight how big the potential is actually in terms of regulating services. That means coastal protection, and that also means blue carbon, so mitigation potential. That needs to be made very clear. So, yeah, that's just a few insights, but I'd love to hear from you.
Yeah, I couldn't agree more. And actually, working on whales and having done that for over 15 years now, that's always been a niche, working within environmental agreements. And then we started actually looking at the science that emerged from 2010 onwards on whales and actually their potential impact on the climate of the planet, so not just biodiversity. And I was really, really surprised when I started working in fora like this one, how little the ocean got acknowledged, given how big it is. But I guess one reason is we are terrestrial species. That's where we mainly dwell and live, and that's where our focus is. And luckily, there has been a good push on environmental education and funding for terrestrial measures against climate change and biodiversity protection. But as funding was just discussed, I think the funding going into measures to protect whales and dolphins, but actually their habitat, the ocean, is just a drop in the ocean, really. So it's very, very little. Something we are trying to change. And of course, whales, everybody loves whales. And we are just trying to use them to engage people in the knowledge that actually the ocean is so important for all of us to survive this climate crisis we're all facing. And they have a huge impact, as I just discussed, but we need to learn more about that. But actually there's also science on fish carbon and other marine life, actually, that has the same functions as was discussed in the first presentation. So I guess, talking money is always not very sexy and not as engaging. But yeah, I mean, a lot of money is actually needed to fund the work we're trying to do and help save the planet.
Well, I'll go one further and say it's not just that we're terrestrial animals, or terrestrial species, it's that we're actually large-bodied apes. And we came from the forests, and we have stereoscopic colour vision for looking through the forest and finding ripe fruit. We have, grasping hands for climbing trees. We come from forest animals. Then we lived on the plains, and now most of us live in cities. And so we are terrestrial. The ocean is a very different environment that we don't intrinsically get the same way, I think, that we get terrestrial ecosystems. And so, but we have a huge brain compared to our body size, and that enables us to adapt and get our head around the oceans. But it's hard. And, the Global Environment Facility, put out its Phase 8, what's it called, the other day, the draft, and, I looked in the whole section on wildlife, and it said wildlife, but reading between the lines, it was all landscape, 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 landscape. And, so I'm sure many of us, were then trying to, get it changed to, land and seascapes. But people just think terrestrial. and it's something we have to constantly work against.
So that's how we're thinking. How are you all thinking? And we've got this Mentimeter online that people who are watching online can submit questions to. And we have one question that's come in, but I'm wondering if there's any questions in the room for any of the panellists. Yes, we have a microphone we'll bring over to you. You have to turn it on. Thank you. So for people watching online, do put in your questions to menti.com.
Thank you. I was not expecting to have the first question, but that's fine. Congratulations. I'm Taru Bahri from Food and Agriculture Organization, Fisheries and Agriculture Division, and congratulations for the panel. I'm really glad to see a lot of the messages that FAO has been advocating for on sustainability and ecosystem approaches being, directly or indirectly echoed by this panel. My question was about the carbon sequestration. So apologies in advance for my ignorance, but my understanding of carbon sequestration is that, to get rid of this excess of carbon is one solution is to trap it and, sequester it in a more or less permanent way. And the first presentation was presenting the algae farming as a solution for carbon sequestration. So I was just wondering how this contributes, to carbon sequestration, because if you put, an investment and efforts in farming algae, I guess that it is for some sort of use, whether it is, industrial or food or whatever. So does this contribute, and to what extent to carbon sequestration? So this is a question I had. Thanks.
Thank you very much for your question. Most unfortunately, Professor Alex Rogers could not join us because we did only have that one delegate. But Julica, did you want to have a go at answering that? I mean, I think my estimate is that probably that with algae, when you grow algae, so that algae itself, the plant, sequesters carbon, but as well you have maybe an impact on the seabed in terms of the storage and the solidification of the seabed, in terms of adding to the seabed. So I don't know exactly, because I don't actually work on algae. I work on fish. So unfortunately, we don't have Alex with us. Did you want to comment, Julika?
Yeah, just very briefly. Sorry, yeah, as I said, no scientist, we would need one to answer this properly. But of course you're right, and when it comes to farming approaches, most of the time that means it's not just left in the ocean, but it's used, as you said. It's harvested and then used. So the question of for how long carbon is stored is a bigger one, but that's actually not only true then for algae, but also in terms of when we look at REDD+ projects, for example, if we restore ecosystems, like what's like durable storage, like about what time frames do we talk, right? So that's a general question that doesn't go for algae only in that context. So maybe just to put a bit context, that's something that we need to deal with in general. And I think, and I hope that the GST, and I don't know if anyone in the room is aware of it, will deal with that as well, like time frames for how long needs carbon to be stored and how effective that is.
Hi, my name's Jeremy from Seychelles, and thank you so much for the presentation. So very engaging. Maybe if I can give some reflections, but also hopefully end with maybe some clear questions. I mean, I think the interesting things with the oceans, and you'll find islands in its weird spot of being terrestrial, but being very much part of this ocean ecosystem. And I think you'll find allies in this space when it comes to discussing this issue, because for us, when we're thinking about that GCF figure, it actually corresponds to the amount that SIDS are getting from the GCF very closely. And I think in our discussion, I think especially thinking about the CMS, it's very interesting to see that while we're talking about this treaty, there's an ongoing treaty of the high seas, and that's 47% of the, the ocean. So I'm wondering in terms of how much we discuss that area, because, there's been discussions about MPAs and area-based management tools. I mean, whether they move or whether they're static. There's great examples like the Wadden Sea, where you've seen 3 countries come together and be able to manage a space. And, the UNESCO Convention's very powerful in that sense to see how we can protect these areas. So I'm wondering, there's existing examples, there's ongoing events, but again, there's this complete parallel process. And I'm wondering about the discussion that's meant to be had next week, and there's meant to be these issues of communities of practice. I like the idea of the matchmaking, in terms of bridging these gaps, but I wonder how much that's actually going to happen and who's going to be the drivers behind that. Are we going to have more states? I mean, could it be more small island states or big ocean states, as we refer to ourselves sometimes? Is it going to be more the conventions in their own way? And I'm wondering in terms of the science, because I'm aware of things like, biodiversity hotspots right now are really seen as based on, vascular plants. It's not based on marine species. So I'm wondering if there's recognition of what biodiversity hotspot looks like in an ocean. So these are just some of their thoughts. So yeah, thank you so much.
Thank you. Do any of you have any reflections? Yeah, Melanie, go ahead.
Yeah, thanks. It's a really good question, and you raised some really good points. And yes, the BB&J negotiations are ongoing. That's biodiversity beyond national jurisdiction, so the high seas. And in fact, CMS covers the high seas, so we cover the species on the high seas as well. But of course, what does that mean legally? In terms of who's responsible for what. And so this new treaty is certainly highly desirable and not before time. But I know that everybody is, all the different players that are sort of here and are also working on the BB&J treaty. I do think that small island states have a hugely important role here, because I come from New Zealand, so my area is the Pacific, and I just know that the Pacific work, and also we do a lot of work in the Pacific Islands for our, with our species. That the perspective, I just talked about, us being, sort of forest apes, but what I do find is that people who live on small islands, obviously by necessity, have such a greater appreciation for the ocean, and I think you have such a strong voice to bring to every single one of these sort of treaties, to keep pushing the message that humanity depends on the oceans and the ocean depends on what we do. Thank you.
Excellent, thank you. We just have a question on the Mentimeter, so I might ask that and then we'll go to the back. Given in Western societies we have many sources of protein and blue carbon includes the fish we eat, is there any argument to stop consuming fish to allow marine ecosystems to recover quicker? I'm handing that over to you. Who wants to answer? Yeah, go Astrid, you start.
Yeah, well, I guess the answer is quite obvious, which is, I think, where everyone is smiling. Of course, I think we all know one of the root causes of the biodiversity crisis in the ocean is overfishing, unregulated fishing specifically. So absolutely, there are living beings in the ocean who actually depend on eating fish, like whales. And then, as was just mentioned, there are small island states, there are people actually living near the coast, people who are really dependent on consuming fish as a source of protein. It's actually an area we work on, because an emerging problem is the intentional hunting of small cetaceans illegally, but in some countries just because, like in Western Africa, Asia, South America, because other marine food sources are so depleted that people just resort to eating small cetaceans, which is also a huge health concern, because they are also heavily polluted oftentimes. So I guess there should be advice by environmental organizations out, and also by, of course, the relevant organizations like the FAO, to reduce fish consumptions and make it more sustainably.
Great. I think we can have a comment. Just if you use the microphone, people online can hear you.
Yeah, thanks for the question. Actually, according to the projections that FAO has, the consumption of fish is projected to increase in the future, not decrease. This is not doesn't mean that this is what we recommend, but these are like the the projections. And also, it's not only small island developing states that rely heavily on fish. It's a lot of developing countries, and fish is the most traded commodity, food commodity among all the food commodities. So that means that huge markets, like economically, it's worth billions per year. So it has a lot of economic livelihoods, food security, implications. So it's, beyond, the carbon sequestration and ecosystem protection. You also need to think of all these dimensions. And then one last comment, because I know we're under time constraints, is that sustainable fishing is probably the best, nature-based solution. Because if you have sustainable fishing, then that means that you are effectively, you're not damaging ecosystems. You're providing, food to people. You're providing employment, and so I think this is important to find this balance between, using natural resources and managing them while not, damaging environment. So I think this is, this is where we should be heading to. Thanks.
I couldn't have said it better myself. Just to mention one thing that we're actually working on in the EU is to get ecosystem and climate impact assessments of fishing done so that we can move to an ecosystem-based management model of fisheries, which does account for the amount of CO2 emissions that are being produced from fishing, the amount of carbon that's being disturbed on the seabed, and the impact also on the fish biomass and the withdrawal of that. And if we, as you say, if we had this sustainable fishing that actually does preserve that food web and the structure and health of that food web and also minimises damage, you have this fantastic win-win-win in terms of food, social justice, environment and climate. So I think it's a really great point. The people at the back wanted to have a question.
Hello, thank you. I'm Lisa Schindler-Murray with RARE, and actually my comment kind of builds off of what you were just saying on the ecosystem-based management model. As I think that when we're talking about blue carbon, it's really important to make the distinction between the carbon cycling and the management actions that enhance blue carbon for climate action. And so for example, we heard a lot about the whale pump and whale and fish biomass in the deep ocean, which is absolutely critical for ocean health and for climate health, but is also distinct from some of the types of actions that can be accounted for in an NDC or a greenhouse gas inventory, at least at the moment, as it's to account for within national jurisdiction. So the line between jurisdiction and BB&J, for example. But given this, I wanted to ask if you could speak to some of the examples on how you're viewing the fisheries and biodiversity related elements of the examples that you shared here in the climate action plans, or if from a policy perspective, if it is, if you're starting to think about it more about bringing out the climate elements in these other types of reports, whether it's biodiversity or development. So sort of where it is being bucketed. Is it are these actions being part of a climate action plan or a part of a development plan, let's say, that enhances the climate elements?
Thank you very much for your question. Julika, Do you want to? I didn't quite exactly understand the
Yeah.
framing of the question actually at the end.
I think you were mainly probably asking those two ladies, probably, right? So the actual potential of oceanic carbon and where it's included or what they envision. Did I get that right?
Yes, yes. Sorry,
Okay.
sorry for the confusion. That's exactly right. Of asking from the examples that we heard at the beginning about how those examples are being integrated into some of the policies, and if that's more of a climate angle that includes fisheries, or if it's more of a fisheries angle that includes climate.
It's a very good question. So just speaking from marine megafauna protection, but also fisheries, there is more knowledge on the fish carbon side of things, and basically your question speaks to what I said at the beginning of my presentation, and the funding we are currently seeking and providing to further the science on this whole subject, because ultimately, of course, the goal is to actually being able to quantify what, for example, whales and dolphins, but fish as well, actually contribute, and how you could financially measure that, and then find a mechanism to integrate it, for example, into NDCs, because that's actually, of course, the language that is needed for a lot of countries on a national basis to justify why they should protect, for example, whales and dolphins. But actually, that's going to be the next step. So the first is to find more funding, I would say next 5 years, to get more numbers and get firmer numbers as well, and then translate that into meaningful policies and actually into monetary amounts as well that can be attributed to certain species.
Thanks. And I've got another question here. And hi everyone, I'm Kathy. I've been following UNFCCC's work on oceans partly as a member of the task force of the Technology Executive Committee, and also really glad to see the attention on oceans, all the events and high-level events and commitments from Glasgow and also this summer. And in a separate capacity, I'm also part of the sustainability team of Deloitte. And as some of you know, WDC is a charity partner of Deloitte. We provide pro bono support and also co-wrote the report, A Drop in the Ocean, that I highly recommend. And so just curious, if our WDC colleagues a question for our WDC colleagues is whether you see a link between what WDC is doing with businesses, for example, with Deloitte, and the UNFCCC policy, because I love both parts and I work in both parts, but sometimes I struggle to see the direct link. So would love to hear from you. Thanks.
Oh, that's an excellent question, and lovely to see that you're here, actually. I didn't know, but it's great. No, I do see the link. And the report you just mentioned, The Drop in the Ocean, is very much what was needed and what is really helpful to show policymakers in terms of the little funding that is put towards protection of the ocean and whales and dolphins as a measure and a potential solution to fight climate change. So I guess that's the big integration that we are having at the moment is actually, and maybe speaks to the question earlier of connecting the dots and bridging the gaps. It's not only NGOs working with IGOs and with governments and conventions, but it's also, of course, working with industry stakeholders and just try and develop the best measures to protect the ocean.
Actually, just a little reflection now that I was thinking about it. I think your question, the previous question as well, was quite interesting in terms of is it in the climate bucket or the development bucket or the biodiversity bucket? And I think that actually is one of the key issues we have been challenged by, actually, is that we're coming from, well, this is a fisheries management or a biodiversity protection thing, but it has benefits and implications for climate. And so from that perspective, the fish and ocean people get it, but the climate people are like, it's sideways. And if you just come directly, if you just go, it's only about climate mitigation or carbon sequestration, the ocean and the fish people go, oh, that's just not really my thing. And trying to, bridge those gaps or connect the two, because we, as people, I think in every area, we constantly silo things to try and manage them, I guess, to stop being overwhelmed. But in this case, it is really a challenge. And I was just thinking there's a project that I was, part of a stakeholder engagement on, which is about actually fishing of the Twilight zone, which was mentioned in the first video, that mesopelagic zone. So, super dark, super deep. They haven't fished it commercially forever because it's just so damn expensive and so damn hard to get there. But we've overfished all of our pelagic species and other species, so they're considering going there to fish it so that they can use it as fish feed for other farmed fish, right? And the question is, well, what is the climate implication of that? What happens to the ocean carbon pump when you start influencing that enormous mass of life that is, driving this pump, and nobody knows, and it's really difficult to make management decisions. I mean, usually we'd fall back on the precautionary principle, right? But it is quite interesting because in that space, they are coming at it from both angles, from both the marine life and fisheries perspective, but also very much from the climate perspective. And there's been some really interesting research done on it. But at the moment, we still haven't seemed to manage to bridge the gap. Does anyone else have any other questions? Yeah.
Hi, Christophe Moquet from Université Côte d'Azur. I'm hearing more and more about fishing toward krill. So we heard about also at the same time about the carbon pump with whales, and I understand that fishing krill will be like a terrifying solution, or not a solution, situation. So I would like to know what you think about that.
It is terrifying, not least because it's happening a lot in the Arctic Ocean, which is one of the last pristine areas in the world when it comes to oceans. So that's one worry about that. But of course, it's also because it's right there in the food net, in the food web and the food chain, and directly impacts up the food chain, so the whales and larger marine megafauna, but also the whole ecosystem. And it is something very much alike, I think, to fishing down in the deepest bottom of the ocean. We shouldn't be doing it, is basically the answer. And I think Melanie had something to add as well.
Not really to add, but just to reiterate that this is the sort of the basis of the marine food web, and we're going to cut it off at the knees, and then the whole ecosystem has could be in danger of collapse. But it's one of these things you can't know for sure until you try it. But once you try it, it's too late.
Yeah, thank you. My question was also toward the regulation, as a current regulation, and if we are equipped with some regulatory framework to prevent that, so if we would need to develop something. Do you know anything?
I mean, it's something that should be covered within the BB&J Convention, but I don't know that it's going in that direction. So,
I believe for the Antarctic fisheries, CAMLR the Commission for the Conservation of Antarctic and Marine Living Resources is responsible for krill fishing in the Antarctic. Yes, the FAO representative is nodding encouragingly at me. Good. And I think maybe in that respect, maybe then it's the regional fisheries management organisations that become responsible. So krill in other areas, maybe because it is again in that high seas area or in the great beyond that is very difficult to manage. We just had another question over here, and there was a couple more questions from Menti. We're getting towards the end, so one more question over here, and then I'll go back to the Menti questions.
Hi, Sarah Briggs. I'm a research assistant at the Centre for Alternative Technology in Wales. And what you were talking about with the potential for whale fall to lock away carbon, what is the impact of increasing ocean acidification on that? And is there anything that we can do to try and prevent that from basically releasing the carbon that's locked away back into the oceans?
That's a very specific question, and I have to admit I'm not a scientist in that area, so I would have to say that I'm not entirely sure. But actually, if you're talking about releasing the carbon back, or are you talking about carbon or carbon dioxide?
So basically reducing the effectiveness of locking away in that carbon sink.
Oh, you mean by actually, but yeah. And also because there are, and less whale falls as well. Yeah, I think that is basically probably something that has mutual impacts on each other. But it's a very interesting question, and I think I'm going to look into that now because you called me out a little bit.
So I just have a couple of questions from online. If states include ocean and coastal elements in their NDCs, will it have an impact as to how the amount of greenhouse gas emissions that needs to be reduced is calculated? I'm looking at you, Julica.
I'm not entirely sure if I got that question right. If it's going to have an effect, could you repeat that?
Will it have an impact?
Impact on how it's calculated?
Yeah. As to how the emissions need to be reduced is calculated.
Maybe this question goes into the direction if, like, that would lead to less ambition in other sectors, or would you interpret it differently? That's the bad thing with online questions. Couldn't verify.
Well, I think it's to do with the NDCs in terms of like introducing more ocean NDCs. How does that impact the calculation of, maybe it's about the calculation of greenhouse gas emissions, and it's not 100%.
Yeah, I don't completely get the question. I think it shouldn't influence actually the way how it's calculated. I mean, of course, we have heard about the fact that for some ecosystems there's still not agreed methodology on how to calculate actually the carbon stored. So that definitely could then have an effect in a way. And as I said before, of course, there is, and that's the whole risk, and that's why we're having a debate about nature-based solutions in general as well, that countries would rather put ecosystems in the NDCs instead of reducing fossil fuels or go to the serious sectors where we need to cut emissions. And that's why I had said before, it's extremely important that we keep this top line up. As much as I want to see ecosystems and especially oceans integrated in the climate agenda, they won't work that well when we don't deliver on just fossil fuel reduction and emission cuts. So I think that's crucial, but it's also not the point to make them look like opposite positions. So it should all come together. Yeah.
Yeah, just jump in. I would agree. It's about reducing emissions and not the calculations. So we need more ambitious NDCs basically on a lot of areas.
It's not an either-or scenario.
But sorry, if I could just add, but maybe by counting them, it makes the country appreciate that resource more and therefore protect it more and enhance it and rehabilitate it. And so by putting it in your NDC, it actually has an impact on making you focus on it and preserve it better.
Absolutely, and I think that's been found again, time and again, hasn't it, generally in society. That brings us to the end of our event. Thank you, everybody, so much for coming. Thank you for your excellent questions and comments, and thank you to those online who have followed.